Hi guys, in this video I'm going to show you how you can create awesome data visualizations. This is a presentation that I gave at the SOA's Predictive Analytics Symposium in Philadelphia in 2019. The topic is on helping actuaries tell visual stories, communicating results clearly, how to change people's minds using data. Now, this is obviously important because as actuaries, we work with statistics, very complex topics that are difficult to communicate. And just by creating a simple picture, you can convince your boss to change your mind. You can convince your client to buy your product. And this can have significant business impact. So I start by telling a story, a real story. When I moved to Chicago last year, I was looking to improve my diet. I was getting into powerlifting, exercising, and I realized that my eating habits were not that healthy. So I started looking at the nutrition labels, which I'm sure all of you are familiar with. And so here's a quick test for you. Which is healthier, the left or the right? In a split second, you would probably say right? Frosted Flakes, are less healthy than Wheaties. But imagine that you didn't have that information. Imagine that you were just looking at all of the numbers, all of the data. You have to compare all of these numbers together, do some calculations, convert grams to maybe some other units. You have to add together saturated fat and polysaturated fat. You have to make a really complex decision in a short amount of time. There are some limitations to this as a data source, right? The serving sizes have to be consistent. The units have to be in consistent format. Each food has its own label. So if I go to a grocery store and I get an entire shopping cart, each item has its own label, right? Its own disparate data source. Now, these are really just spreadsheets, right? Each label is a spreadsheet with information, and they're spread out over many areas. They're disconnected. So I started looking at my Instacart orders. Now, Instacart is a delivery service that gives you your groceries whenever you want them, within a few hours. Someone will drive to the grocery store, buy everything that you order, and then deliver it to you. And I started using Instacart because I was living in the city. It was a long ways to the grocery store. I could either walk there and carry the grocery bags back several times per week, or I could take a train or take a lift. Then it would take longer, and it would just be really inconvenient. So I started ordering all of my groceries online. And I had a history of about 6 months of grocery orders. So I went onto Instacart's website, and I logged into their API using R, and I downloaded my grocery history. So I could see all of the names of the groceries. And if you want some more of the details, I can share with you how I actually did this. So here you can see on the x-axis the date, and on the y-axis you see my calories per day. So my target was about 3,000 calories. I wasn't quite hitting that target in April, and then I started really paying more attention to my calories, ordering more breads, eating more pasta, eating a lot of rice, getting those high-calorie foods. And then I started falling behind on my study routine. I was studying for an actuarial exam, and so I stopped going to the gym less. My calories decreased to less than 3,000 per day. And then in June, I took the actuarial exam, and I got back into my normal routine. Then I went away for PTO, and you can see I didn't order groceries for a few weeks, and so my calories dipped down. I can get a daily benchmark. Based on my height and weight, I get a body mass index. And I get my calories, my protein, my total fat, and so forth. So in a perfect world, right? I could set up a benchmark for what I would be eating. Here on the y-axis, you see the percentage of that daily benchmark. You can see that my sodium starts out really high. I'm eating a lot of hungry man meals, like mac and cheese, like processed food that has salt as a preservative. I'm eating 2.5 times as much salt as I should be eating. My cholesterol is way down here on the bottom in the purple, which is fairly low. My fiber starts out low, and I started eating more breads and pasta, and that increases. My total calories in the middle is about 100% of what I'm targeting. My sugar is slowly decreasing. As I cut out processed food, I stop eating candy, drinking any type of sugared beverage, eating cereal for breakfast, things like that. My cholesterol slowly starts to increase gradually, and as I begin to eat eggs in the morning for breakfast, my cholesterol keeps increasing. Meanwhile, I continue to pay attention to my sugar intake, and my sugar is less than half of my target, which is good. Sodium is still at about 200%, but it's slowly getting lower as I'm moving away from processed foods and into whole fruits and vegetables. I'm starting to cook my own meals now as opposed to buying packaged meals. Now, the overall trend here is that all of the lines are moving closer to the black line. Now, if this was perfect, all of the lines would be on top of this black line. In other words, I would be eating 100% of my targeted benchmark every day. Now, what this picture illustrates is a complex process of 6 months of time. And, maybe in your business problems, maybe you don't know exactly what the answer is. Maybe it's open-ended. But maybe having some type of visualization like this will allow you to pin down what you should be focusing on. In this example, I didn't know exactly what I was looking for, but I knew that if I just got all of the data into the right picture, I could then see. So the takeaway is get access to the data and then find a way of displaying it. There are really two use cases for data visualization. There's exploration and there's communication. Now, this is a huge source of confusion because they involve different tools, different sides of the brain, different processes. In exploration, the goal is to quickly discover. You need speed, you need iteration, agility, you need a lot of dimensions, you need R and Python. In communication, you need the exact opposite. You need simplicity, professionalism, consistency, and you need to be able to think creatively, think without using your neocortex, thinking more emotionally. Tools like Power BI and Tableau are more useful. This is when you communicate your results to a client, when you give that big presentation. Visualization is really a process. Hadley Wickham talks about the steps involved, going from importing raw data to communicating those results. R has a great variety of tools in the tidyverse, which allow you to create all of these steps at once. The ggplot2 library is a data visualization tool in R. And as actuaries, you often have to conform to business standards. You want to make your graphs look professional. So this is the default graphics. And you can quickly create a template. So the template applies your custom logo to the graph. It will change the style, the font. It will add copyright, and it will help to improve the branding of your business. There's a saying in programming, DRY, which is do not repeat yourself. Now, when you're writing a script, this will be very, very, very important, and it will save you a lot of time. Data visualization is often done with click and drag menus, where you are going through a series of steps very manually. If you can automate that into code, then you can get the best of both worlds. You can create content that is communicatable and professional, but then you can also iterate through it quickly. Now, here's some pseudocode in R. You can start with a SQL query to a database. You can then join that data together in order to combine different data sources. Like, remember in the Instacart example, right? I had data sources from each food. Each food had its own nutrition label, which was its own spreadsheet, and all of that had to be collected together. That's just like a left join. Then you can create some visualization. So ggplot2 in the R has tools for doing that. And then you do some visualization, and then you can tack on a custom theme. So this is doing all of those steps that Hadley Wickham talked about in just a few lines of code. This is what's possible when you create your own custom libraries. The best graphs are easy to read. Take this example. On the x-axis, it says number of readmissions. On the y-axis, it just says density. How are you supposed to understand what this means? They're hospital readmissions, but it's really not easy. How do you translate this information into English? Here's the same information, but in a different graph. You can see exactly the number of hospital readmissions for each value. You can see that there are about 1,000 hospitals with between 50 to 70 readmissions. There are about 2,000 hospitals with between 30 to 50 readmissions. And so this combines all of the tabular information that you get from looking at a spreadsheet with the visual information of looking at a graph. So what is it really doing? Well, the labels are clearly lined up on the X and Y axes. And the labels are also aligned to the height of the bars. I'm using consistent font and color schemes and so forth. Graphs also have to be unambiguous. A common graph that I see actuaries use is this mixed bar type, where you have a line graph and a bar graph at once. You're basically taking two images and putting them on top of each other to save space. In this example, you have actual versus expected by state. So this is the actual hospital readmissions versus the predicted hospital readmissions. But which of these axes is actual and which of these axes is predicted? I can see, orange is average of expected, and blue is average of predicted, but they both have the same range from 14 to 17, from 14 to 16. So there's actually no way to tell, right? This graph is uninvertible. There's no way to go from the table of information to the graph, which is a problem. So another way to look at this would be to look at a XY plot, where the x-axis is the actual readmissions, the y-axis is the expected readmissions, and then each point would be a hospital. So you could see Massachusetts has higher expected readmissions than actual readmissions, whereas Pennsylvania has an AVE ratio of just about 1. You can also show the uncertainty using box plots. So the advantage of box plots is that they show the spread of points instead of just showing an average. So you can see Pennsylvania has a number of hospitals that are low on AVE, but also hospitals that are higher. When it comes to colors, there is an exact science to choosing the colors for your graphs. One tool that I use is a color wheel. So if the best colors are complementary to each other. If I have a graph where I need to use two different color values, choose values which are opposite from each other on the color wheel. Blue works well with yellow. Green works well with pink. Or like this teal color is complementary to orange. Or if you have a graph with say 3 points, and you want 1 point to be blue, then choose the other points to be green and red. Now you can adjust the shade of this entire color wheel to match the colors of your business. Here's just an example, okay? If you just assign random colors to a graph, it can look garbage, just absolutely terrible. If you then go onto your company website and you get the color values, and you look up on a table and you save these somewhere into a template, with whatever you're using. If you're using Power BI, if you're using Tableau, if you're using ggplot, and then you can store these into a custom library so that every time you create a visualization, it will have these colors. Finally, the most important part of visualization is about emotional intelligence. I talked about using two different parts of your brain, using your neocortex or using your lizard brain. The neocortex does all the complex computation. The lizard brain reasons emotionally. Now, people don't like to use the neocortex unless they really need to. That's just the way human beings are. We're wired to be efficient. We're wired to be lazy. And it's really easy to not have the right balance between soft content and hard content. Fortunately, though, this is not something that is new. This is an age-old problem, as old as humanity is. One book that helps is called How to Win Friends and Influence People by Dale Carnegie. A few bullet points from this book were realize that you can never win an argument if you're presenting something, if you're creating a graph, and you create something that's adversarial, that's confrontational to the audience's viewpoint, it is very unlikely that you will change their mind. You can also let the other person see the pattern and come to the conclusion themselves. Don't have a conclusion slide or don't have a summary of key takeaways. Instead, just try to present the results in a scientific manner and let them come to the conclusion themselves. Put yourself in the other person's shoes whenever possible. Use their language. If they're used to seeing a graph in a specific way, then show it in that same way. Don't change the format just because you can. Be friendly, after all, because at the end of the day, all that data visualization is a way of communicating with someone. Like right now, I'm recording this video and I'm communicating with people through video. And then get the other person agreeing with you. Reinforce. Find ways of tapping into their existing knowledge. These are all just basic, sales techniques, emotional intelligence techniques. When you interweave these into your data visualizations, you tell convincing stories, you will find that the impact of your results will drastically improve. So I would say, to summarize this whole presentation is one, recognize the difference between exploration and communication. When you are focusing on exploration, try to focus on speed and iteration, flexibility. This is when all of the technical R, Python, Tableau skills really come into play. For communication, focus on professionalism, simplicity, consistency. Finally, realize that data visualization is just like any other form of communication, and that body language, text, speech, appearance, voice, all of these other things are just as important.